So today, for this Unit 4, Section 6 notes, we're going to actually now talk about quadrilaterals and how we can determine if they are a rectangle, a rhombus, or a square. So that's our objective today. So first of all, we're going to talk about some new conditions. So when you're given a parallelogram with certain properties, you can use the theorems below to determine whether the parallelogram is a rectangle. So if one angle of a parallelogram is a right angle, then the parallelogram is a rectangle. So remember, the first condition here is if it's a parallelogram. Now obviously that's because if angle A is a right angle, then angle C is a right angle because they're opposite angles if it's a parallelogram. And then B and D would also be right angles because B and D are supplementary to angle A if it's parallelogram, because both consecutive angles to angle A are supplementary. Consecutive angles to A are supplementary to so B and D would be supplementary. Then the next one says if the diagonals of a parallelogram are congruent. Again, this is a parallelogram. If it's a parallelogram and the diagonals are congruent, then it's a rectangle. So we're going to use these properties with our next problem. So this is an example 1. This is our carpentry application. So it says a manufacturer builds a mold for a desktop so that AB is congruent to CD and BC is congruent to DA, and the measure of angle ABC is 90 degrees. Why must ABCD be a rectangle? So first I'm going to mark what's given. These are the sides that it says are congruent. AB is congruent to CD and BC is congruent to DA. Well, notice those are opposite sides. And if the opposite sides are congruent, then I can say this is a parallelogram, right? And what we just learned was since ABCD is a parallelogram and one angle is a right angle, ABCD is a rectangle. So if you need to write this down, go ahead and pause the video and then come back to me when you're done. All right, so our next example, this is our check it out example. This one says a carpenter square can be used to test that an angle is a right angle. How could the contractor use a carpenter square and a tape measure to check that the frame is a rectangle? Well, if I'm a builder, then I'm going to make XW so the same length as YZ. And I'm going to make the length of XY the same as WZ. Because that's what we do when we're carpenters. Opposite sides would be congruent, right? So if opposite sides are congruent here, and that's what we just talked about, same height, right? And then same length here. Then if opposite sides were congruent, then I could just measure one of those angles. I could measure an angle down here at W. And see if that's square down there, and if that's square down there, then the rest of it has to be a parallelogram. So if we were to talk about Y, both pairs of opposite sides of quadrilateral WXYZ are congruent, so that WXYZ is a parallelogram. The contractor can use a carpenter square to see if one of the angles of WXYZ is a right angle, and if one angle is a right angle, then the frame is a rectangle. Again, if you need to write this down, go ahead and pause the video. Come back to me when you're done. All right, now we're going to talk about some more conditions. So again, if this time we're going to talk about whether something's a rhombus or not. So on this one, if we've got a parallelogram and one pair of consecutive sides is congruent, then we can say this is a rhombus. And the reason for that is because if it's a parallelogram, we know that opposite sides are congruent. So if FE is congruent with EH, then we also know that FG would be congruent with EH, and we know that FE would be we know that FE would be congruent with GH, and so we would know this, right? And then we would know EH is congruent with FG. So all four sides would be congruent, so that's why it's a rhombus, right? Then the next one says if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So here again, if it's a parallelogram and the diagonals are perpendicular, then it's a rhombus. The last one is, again, if it's a parallelogram and the diagonals bisect a pair of opposite angles, then the parallelogram is a rhombus. Okay? So in order to apply the theorems we just talked about, the quadrilateral must first be a parallelogram. Really, really, really important. To prove that a given quadrilateral is a square, it is sufficient to show that the figure is both a rectangle and a rhombus. So you will explain this is true as we work through these exercises. So you can also prove that the given quadrilateral is a rectangle, rhombus, or square by using the definitions of special quadrilaterals, and we're going to do that as well. So right here, so example 2a says, applying the conditions for a special parallelogram. So determine if the conclusion is valid, and if not, tell what additional information is needed to make it valid. So we're going to go ahead and mark what's given to us here. It says EF is congruent with FG. Well, that's certainly not enough to tell me anything, because that's just two sides. A pair of consecutive sides, yes, but just two sides. Then the other piece of information that's given us to us here is that EG is perpendicular to FH. Well, EG is this diagonal and FH is this diagonal, and it's telling us that they are perpendicular. So that means all four of those angles in there would be right angles. Well, again, the fact that those are right angles and I have one pair of consecutive sides that is congruent doesn't give me enough information. What I would need to know with either one of those individual conditions, we could use this one and say it was parallel, would be enough for me to say that it was parallelogram, or the other one, this one. And it would be enough to tell me that it was parallelogram. However, a rhombus. So I don't have enough information because I don't know that it's a parallelogram. So let's go through this next problem. So here it says, determine if the conclusion is valid. If not, tell what additional information is needed to make it valid. So we're given that EB is congruent to BG. EB and BG, and also FB and BH. Well, that shows me that the diagonals are bisecting each other. So that is enough for me to say that this shape is a parallelogram, right? Because the diagonals bisect each other, it's a parallelogram. The next one says, is it a rectangle? Well, let's see what other information is given to us here. So it says that EG is congruent with what? FH. Well, if that's true, and it's a parallelogram, if the diagonals are congruent and it's a parallelogram, then we can say it's a rectangle. The next condition that's shown in this drawing is that we got two triangles, is given. We have EBF is congruent with EBH. Well, I see that we got two ticks here, and two ticks here, and one tick here. So because these are the corresponding sides that are left, we could say that those are congruent, right? So now, because it's a parallelogram and we have a pair of consecutive sides that are congruent, we can say it's a rhombus. Now, because we said it was a rectangle in step 2 and a rhombus in step 3, we can absolutely say that this is a square. Again, put me on pause if you need to write this stuff down. So now, this next one says, check it out. Example 2. Determine if the conclusion is valid, and if not, tell what additional information is needed to make it valid. So this one says angle ABC is a right angle. Angle ABC is right here. Well, that's one right angle. Certainly not enough information for me. However, if I knew that it was a parallelogram, it would be enough information. So it's not valid because we don't know it's a parallelogram.